lesson again. All right, today we are talking about constructors. So a bit of recap from what we've learned already. All objects that we create are going to have a state, which is determined by their instance variables and the values within those instance variables. And the state of an object is initialized when we call the constructor for that object's class. So if I have a rectangle class with instance variables width and height, I can initialize my object's state by calling the rectangle constructor, take two parameters, and I assign those to my instance variables. Instance variables, constructor, and the parameters, like I just said, the parameters for the constructor are what we use to initialize our class's instance variables. If we ever create a class that doesn't have a constructor, if we don't include one, Java will automatically create one. It'll create a default constructor that accepts no arguments, and it'll initialize each of the instance variables to have a default value. So numbers are going to have a 0. Classes are going to have a null reference. They're not going to be instantiated. So we'll have just a bunch of empty values. So if we have this rectangle.java class, we've got our instance variables and we've got a toString method, but we do not have a constructor. So if I create this my program.java, where I'm making a rectangle object and initializing it with this default constructor, and I print my rect object, I'm going to see my toString. I'm going to see rectangle width comma height, and width and height are both going to be initialized by this default constructor to be 0. So we'll get rectangle width comma height 0 comma 0. They filled in with nothing. Now, since we can use objects just like we can use basically any other type of variable, it makes sense that we can have variables within our classes have a class as their type. We can have our instance variables be objects. And to demonstrate this, we're going to build a superhero class. So we have our wonderful superhero here. We're going to create a superhero class such that every hero has 2 different attributes. They've got a name and they have a superpower. So those 2 values are going to be our instance variables for our class. And the relationship between an object and its instance variables is known as a has-a relationship. So a superhero has a name, a superhero has a power. So the power, if we go a little deeper, power is also going to have 2 attributes. A power is going to have a name, and a power is going to have a strength. So notice that P is capitalized. So since we have a value that's going to have multiple attributes, power should also be a class. So within our superhero class, one of our instance variables is itself going to be of a type that is a class. So if I build a small flowchart, I can keep track of all of my instance variables and all of the attributes for all the classes we're going to build. So we're going to have our superhero class that has 2 attributes, 2 instance variables. We've got our name, which is a string, and we have our superpower, which is of the power class. And then the power class has 2 attributes, 2 instance variables. We have the name, which is a string, and we have a strength, which is an integer, so how strong their power is. And let's start by building that power class out so that we can use it when we actually build the superhero class. So in Java, when we're building classes, each individual class needs to be in its own file. So we'll need to create a power.java file. And then within that file, we can create our power class like this. It's a public class power. We've got our instance variables, name and strength. Both of those should be private, like we learned last class. And we have our power constructor, where we take two values, we take a string n and an int s. We assign our name to have that value n and our strength to have that value s, or initializing both of our instance variables. We should also include accessor methods for each of our instance variables, because we should be able to show the user what the name and strength of our power is. We might also want to include some mutator methods, but we'll get to that a little bit later. So now that we have that power class implemented, we can build the superhero class. So we've got our public class superhero. We're going to define our instance variables now. We've got our name and our superpower. Name is a string, and superpower is a power object. Both of those are going to be private. All of our instance variables still should be private. And we have our public superhero with our string n and our power p. So name is going to be assigned that parameter n, and superpower is going to be assigned that parameter p. Just like any other variable type, we're totally allowed to use objects of class types that we have created within our other classes. So I'm not restricted to only classes that already exist within Java. I can create classes and use those within my other classes. Now, there is a slight problem in this code. This line in particular, superpower equals p, does raise a potential issue. So let's look at an example and see how an issue might occur. So if I create a power object and call it flight, I'm going to create a new power. The power's name is flight. The power's strength is 5. Perfect. We have a flight power. And I can create two superheroes. I can create Super Duper. It's a new superhero with the name Duper and the power of flight. And I have the superhero Super Flooper, also a new superhero with the name Flooper. He also has the power of flight. Now, if we look at our little diagram, Super Duper and Super Flooper, both of these are boxes with boxes inside. These are our objects. So our name for each is going to be different, obviously, and our superpower is going to have the same stuff inside, because they're both getting that power of flight. Now, if I say Super Flooper dot set power strength to 10, what do we think is going to happen?
Update the power variable?
It'll update the power's strength. Yeah, but is it going to update for only Super Flooper?
For both of them?
It will update both of them. Now, why is it going to update both of them?
Because they use the same variable, is that the right word?
Exactly, because they're using the same variable, which this variable flight, it's a reference to some object data. And in our constructor, when we say superpower equals p, we're assigning this variable to have the same reference. So when we are passing that same object, both Super Duper and Super Flooper, that superpower object, that's pointing towards the same exact object data. So if I change one, the other one is also going to change, because it's not actually a different one. They're the same exact object data. They have the same reference. So if we remember the word for this, they are aliases, superpower instances within Super Duper and Super Flooper. They are aliases of each other because we've given them both the same exact reference. So in order to solve this problem, when we, in our constructor, when we get a power object, we're going to make a new power object with the same instance values as we got from the parameter. So we've got our same setup in our superhero class, and then our constructor, the first line is the same, second line is the same, but we're not saying superpower equals p anymore. We're not just assigning the same reference. what we're doing is we are calling the power constructor, we're making a new power object with the passed in parameters, name and strength. That's where we're using our two accessor methods. So we're getting the name and getting the strength from our power P to create a new power to assign to our individual superheroes superpower. And then we have our accessors and mutators for this class. So what this does for us is, with that same block of code as before, our superheroes now, even though their superpowers have the same contents, they no longer are aliases of each other. They're no longer the exact same object. So when I set the power strength in Super Flooper to be 10, only Super Flooper's strength is updated here. Does that all make sense? All right, I'm gonna pause real quick. All right, so I have implemented that code from the presentation. If we look at our power.java, remember our class name needs to match the name of our file. So our power.java has the power class, got our instance variables, got our constructor. I've got my getters for both name and strength. I don't have a setter method for the name because we don't really need to be able to change the name of our superpower. I have decided that that's not how I want to implement this class. I do, however, want to be able to change the strength of the superpower. So I did create a mutator for that instance variable. And I also have a toString method for this class. And within my superhero class, I have all the same stuff. I have the option, I can delete my my good constructor line where I'm making a new power, set it equal to just the parameter again. I've got my getters for my name and my superpower's name and my superpower strength. And I can also set my superpower strength. I'm just going to call the getters and setters within the power class. So if I run this with my previous bad constructor line, I run this. We've got our hero called Duper with the power of flight, strength of 5. Flooper, same thing. And if I change Flooper's strength, both are now 10. So if I go back, fix my 2 lines of code, comment out the bad one, comment in the good one, we can see now my code works as expected. I have a strength of 10 for Flooper and still only a strength of 5 for Duper. All right.